Welcome back. Today's notes are going to be on inverse trig. And this is going to be page 32. And we will be writing this in our table of contents. So I ran out of room on my first page of my table of contents, so I'm going to go ahead and flip it. And this is going to be on page 32. Inverse trig. Okay. So we know what trig stands for. Trig is trigonometric ratios, and those stay the same. But now we're going to do the inverse. So let's draw an example. And again, we're going to draw a right triangle because that's always what we're working with. And up until this point, we've always been solving for a side length. Well, now when it's the inverse trig, we'll be solving for an angle. And remember, that's called theta. And this is finding an angle. So I'm going to have theta 1342. Okay, let's say that's our first example. SOHCAHTOA does not change, so I'm going to write that again. Okay, this always stays the same. When you're doing regular trig or inverse trig, SOHCAHTOA is always the same. Okay, now, right here, we're missing an angle. So that's what we're trying to find. So the first thing you always do is we want to determine which ratio are we going to use. Are we going to use sine, cosine, tangent? Okay. So let's label what we have. Well, I always like to start with the hypotenuse because it's across from that right angle. So we have hypotenuse. And then if we're at theta, 13 is opposite. So looking at that, we have opposite hypotenuse. Well, which one's opposite hypotenuse? Sine is opposite hypotenuse. So we are going to be using sine here. And you write it the exact same as you've been writing it. Sine of the angle equals opposite over hypotenuse. But this time we don't have the angle. So I'm going to write sine of the angle's theta equals opposite over hypotenuse. 13 over 42. Again, we've been solving for side lengths up until this point. Now we need to solve for an angle measure. So, it's called inverse trig because you're going to do the inverse of sine. So what that looks like is I'm going to write sine inverse, which is a -1 at the top, on this side, and I'm going to write it on this side. It works the same as if you're solving a multiplication problem or anything like that. Whatever you do to one side of the equation, you have to do to the other side. So this sine inverse and this sine, those actually cancel out. And I'm left with theta equals sine inverse of 13 over 42. Okay? And this is where you're going to pull out your calculator. Make sure you're in degree. And you'll notice that above sine, it looks like sine inverse. See? Sine inverse, sine inverse. So that's the button we're going to use. How you get to that? Excuse me. How you get to that is you press second and then sine, and you'll notice that sine inverse pops up. 13 over 42, enter. And that is your degree. So that means theta equals 18.03 degrees because we just solved for an angle. Okay, so I'm going to talk through it one more time. The first thing you're going to do is determine which parts you're given so that you know which ratio to use, sine, cosine, or tangent. You set up your ratio, sine of theta or cosine of theta, tangent of theta, equals whatever that ratio is. You take the inverse of both sides and you put that right in your calculator. Okay? I want you to try one before I go over it. So go ahead and try this problem. Okay, so go ahead and try that one. Start by setting it up and see if you can find theta. All right, so when we set this up, we're going to figure out what parts we're given. Well, we can label our hypotenuse first, so that's right here. And then looking at this theta, 15 is adjacent. So which ratio uses adjacent and hypotenuse? That would be cosine. So this is going to be cosine of theta equals adjacent over hypotenuse. And now we take the inverse. And I'm going to get those cancel out. So that's going to be theta equals the inverse of cosine, 15 over 25. And I'm going to put that in my calculator. $53.13. Okay. Now I'm going to have you do two more examples. So go ahead and do these two, and then I'm going to go over them after you plug in your answers. Okay, so go ahead and do those two. So for example 2, looking at theta, well, hypotenuse would be over here, so that we don't have that, but we have opposite and adjacent. And using SOHCAHTOA, which I'm going to rewrite down here so I can see it. Which one uses opposite and adjacent? That would be tangent. So this is going to be tangent of theta equals opposite over adjacent. Take the inverse. Those cancel. So I'm left with theta equals tangent inverse of 4 over 5. And I'm going to put that on my calculator. 36.66 degrees. And then the last one, I can label my hypotenuse first. And then looking at theta, 21 is opposite. So opposite hypotenuse, that's going to be sine of theta equals opposite over hypotenuse. Take the inverse. Those cancel. And I get theta equals the inverse sine, 21 over 24. Put that in my calculator. 61.04. Okay, and that's all for those notes. Thank you for watching.